In lesson 5.3, we're going to divide polynomials using long division that we did in Algebra 1, and then we're going to move on to the shortcut, which is called synthetic division. How can you use division of polynomials in manufacturing? Machinists needed 32x squared plus x square inches of metal to make a square pipe 8x inches long. In figuring the area needed, she allowed a fixed amount of metal for overlap of the seam. If the width of the finished pipe will be x inches, how wide is the seam? You can use a quotient of polynomials to help find the answer. I went ahead and rewrote this as each term over the denominator separately. Now we can cancel. Anything divided by itself is 1. Power divided by power, we subtract exponents. And anything divided by itself is 1. 15 divided by 5 is 3. Anything divided by itself is 1. Power divided by power, we subtract exponents. So b cubed divided by b, 3 minus 1 is 2. 10 divided by 5 is 2. 3 minus 2, there we go again, 3 minus 1 is 2. 4 minus 1 is 3. So our final answer, we just have an a left in the first term, minus 3b squared in the second term, plus 2a squared b cubed left in the third term. Okay, we're going to use long division first before you learn the shortcut to find the quotient. We're using that division algorithm you learned in elementary school. So I'm asking myself the question, what do I need to take x times to get x squared? And the answer is x. So then I'm going to multiply x times both terms here. So x times x is x squared, and x times negative 5 is negative 5x. And then we subtract. And wouldn't you know, x squared minus x squared is nothing. Minus a negative is the same as a plus, so I end up with positive 3x. Bring down the next term, just like we did in grade school. And then I ask the question, what do I need to take x times to get 3x? And the answer is, of course, 3. So 3 times x is 3x, 3 times negative 5 is negative 15, and we have no remainder and went in perfectly. If you're curious, such as on a quiz or test, and wanted to do a check step, you could undo division with multiplication. I FOIL this out, I get x squared minus 5x plus 3x minus 15. Wouldn't you know, I get what I started with. Check step worked, I'm happy with my answer. And they're getting a little bit fancy here in the Algebra 2 book. And remember that negative exponent means division. You may also see it written with a division bar. Now, I use a commutative property and put a first because it seems like the right thing to do. And so I'm going to ask myself the question again. What do I need to take negative a times to get positive a squared? Well, negative times negative is a positive, so I'm going to take it times negative a. So I have a squared minus 2a, and then we subtract. And minus negative is the same as a plus, so I end up with negative 3a. What do I need to take? Negative a times to get negative 3a. That would be 3. So 3 times negative a is negative 3a. 3 times 2 is 6. Ooh, they're not the same. So this time I'm going to get a remainder of negative 3. And remember again from grade school, when we have a remainder, we're going to take a remainder and write it over what we were dividing by. So negative a plus 2, which looks a little weird. So whoever typeset the book is more likely to write it as 2 minus a, but these mean the same thing. Oh yes, this was a multiple choice question. That's always nice to finish up on. So I suppose the correct choice looks like it was D. Synthetic division is a simpler process for dividing a polynomial by a binomial. Suppose you want to divide 5x cubed minus 13x squared plus 10x minus 8 by x minus 2 using long division. Compare the coefficients in this with those in the example. Well, where there was an x cubed, I just wrote down the 5. I just wrote down the negative 13. I just wrote down the 10. I just wrote down the negative 8. So I'm not writing down all the variables and their exponents. Now, every time we divide by a nice binomial with the coefficient of 1 in front of the x, this number is always going to be what we multiply by here. So if we have a 5 here, we need a 5 there. So my 5 is going to drop down. And then we're going to take 5 times 2 is 10. I see a 10. And add 2 times negative 3 is negative 6. Okay, I see positive 6, but we're subtracting it. So, you know, subtracting a positive or adding a negative, either way, I get 4. Multiply 2 times 4 is 8. Add, I get a remainder of 0. As I did there, you can tell, right? Synthetic division is one of my favorite topics. We start off by putting the root, so what would give us a 0 here goes in the box, and then the coefficients. So the coefficient of x cubed is 1, x squared is negative 4, x is 6, and the constant's negative 4. So they were nice and wrote it in descending order. If they don't, you need to put it in descending order before you start, but that's not a big deal. Drop down the 1, multiply, add, multiply, add, multiply, add, and this would be our remainder if we had one, but since we have a 0 there, it came out even. So I'm going to make it unsynthetic now, reconstitute it, so to say. So I have no remainder, so this is now my constant, and my x term and my x squared. So I was x cubed, I divided by an x, and now my highest exponent is going to be x squared. And I didn't write the 1 because 1 times anything is solve. And if you really wanted to, you could multiply that by x minus 2 as a check step. At this point, I am going to respectfully disagree with the book that this is a good idea. I'm going to show you how to use synthetic division with a coefficient other than 1. But I think definition of shortcut is it should be shorter. I would do this by long division. I'm going to show you their way first. So first, they use division to rewrite the divisor so it has a coefficient of 1. So they divided everything by 2. And isn't that a thing of beauty? Okay, now the synthetic division isn't that big of a deal. Drop down the 2, multiply, add, and we get a remainder of 2. But wait, there's more. So they have the result is 2y cubed plus 2y squared minus 2y plus 0, they didn't write down the 0, plus 2 over y minus 2. Oh, but we can't leave our answer as a complex fraction. So just to simplify that fraction, dividing is the same as multiplying by the reciprocal. So the fraction part should be 4 over 2y minus 1. In my humble opinion, that is not that's not a good shortcut because it is long. I would just do this by long division. You know, when I go to write this down to do my long division, I have 4y to the 4th, and there's no y cubed. So just like in the number 5,280, I'm going to put a plus 0 for a spaceholder for my y cubed. And then I've got minus 5y squared plus 2y plus 4. And we'll go back to the simple question. What do I need to take 2y times to get 4y to the 4th? 2y cubed. So I've got 4y to the 4th minus 2y cubed. And subtract. Minus negatives a plus. Bring down my next term. what do I need to take 2y times to get 2y cubed? Why, that would be y squared. So now I've got 2y cubed minus y squared. And I subtract minus negatives a plus. I've got negative 4y squared. Bring down my next term. What do I need to take 2y times to get negative 4y squared? Why, that would be negative 2y. So I've got negative 4y squared plus 2y. Why, that's handy. And bring down my last term. So my remainder is 4. So with long division, I don't have to mess with all of this fraction hooey that they did and all of this. I'm just done in, I think, a lot less time. In my mind, a shortcut should make things go faster. If it doesn't, it is not short. Great summary here. Use the division algorithm or synthetic division to divide polynomials.